Hello, and welcome back to another exciting episode of Teach Me in 10. I'm your host, Heather James, and this is Technology Network's video series where we challenge scientists to teach us fascinating research and scientific concepts in less than 10 minutes. In this episode, I'm speaking with Dr. Kyle Luttgeharm, a senior product manager of the proteoanalyzer system at Agilent Technologies, and we'll be discussing how automated protein analysis leads to reliable results. And before we go any further, I'm delighted to say that this episode is kindly brought to you by Agilent Technologies. Agilent supports scientists in 110 countries in cutting-edge life science research, patient diagnostics, and testing required to ensure the safety of water, food, and pharmaceuticals. To learn more about Agilent, you can click the links that we've left in the description. So without further ado, you're about to watch this incredible Teach Me in 10 episode in full. Hi, Kyle. Thank you so much for joining me today. How are you doing?
I'm doing great. Thank you for having me.
It's our pleasure. Now, as you know, we only have 10 minutes for this session, and you have to cover some pretty complex questions. So I'm going to hop right in. So firstly, could you give us a brief overview of the proteoanalyzer system, please?
Absolutely. The Agilent proteoanalyzer is a new parallel capillary electrophoresis instrument that was designed for the analysis of proteins. It uses a 12-channel capillary array that allows for the parallel separation and subsequent analysis of those 12 samples, each in their own discrete capillaries. The system uses a high-pressure syringe pump, which is used to pump the different solutions through the capillaries. And so between every run, the capillaries are actually flushed with a cleaning and conditioning solution, followed by fresh sieving gel. And this sieving gel then separates the injected proteins by size, with the smaller ones passing by the detector before the larger ones.
Thank you so much for that excellent overview of the system. So following up from that, I know a lot of people use SDS Page for this type of analysis. How does this system differ from that manual technique?
Really, it comes down to automation and digital data. The overall principle behind the two techniques are the exact same. They both use SDS to denature the protein and ensure a constant mass to charge ratio, and they both use a polymer to separate those proteins then according to their size. And then they both use some sort of method for detection of the protein. But with SDS Page, you have to manually load your gel, monitor the run, perform manual staining and destaining steps, followed by manual annotation. And this entire process can take up to 24 hours to complete. On the other hand, the proteoanalyzer will automatically inject those samples directly from a 96 wall plate, separate them so that you can see the different sizes that are present, and then produce high quality digital data for 12 samples, all in about 30 minutes. So once your run of 12 samples is complete, the instrument automatically moves on to the next row of 12s without any user intervention. And so then you can look at the data for that first set while the second set is actually running. Another major difference is the proteoanalyzer uses fluorescent detection, which provides us a 3-log quantitative linear dynamic range compared to traditional Kumasi gels, which have about a 2-log quantitative dynamic range at best. And so this really gives you more insight into the composition of your sample by being able to detect low-level impurities.
Excellent. It really feels like we're stepping into the lab of the future here by automating these processes and making them so much faster. Now, I can see that you have an assay for this instrument. Can you tell me about how that works and how it performs?
Absolutely. So like I previously stated, the proteoanalyzer uses fluorescent detection. So the first thing we need to do is actually label our protein sample. All the reagents that are required for this are included in the kit. So the user simply makes a master mix of some of these reagents and then pipettes 29 microliters of the master mix into each well and adds 1 microliter of their sample. You just seal up the plate, vortex it, heat it in a thermocycler for 10 minutes. And so in total, you're looking about 20 minutes to label your samples with about 10 minutes hands-on time and then that 10 minutes heat incubation. Once the incubation is complete, you just take the seal off and load the plate directly on the instrument. No further pipetting steps are needed. And the exciting thing is at that point, the proteoanalyzer takes everything over. And so the assay you can really prepare a lot of samples, up to 96 at once in a single plate, and then load it up on the instrument and then go home. And the system's going to analyze those data row after row after row. And all of that's going to be waiting for you when you get back to the lab. Our assay allows sizing of a wide variety of proteins. We have sizing from 10 to 240 kilodaltons, and this uses the ladder that Agilent provides. And we validated that sizing with some standard proteins. And so we see excellent sizing accuracy with less than 10% error for both BSA and CA2, and sizing precision values of less than 5%. Our quantitation reproducibility for these standard proteins is also less than 15%. So we're getting accurate sizing and great precision on both sizing and quantification. While sizing and quantification are both important factors, resolution of the assay is also extremely important because this allows for separation of closely sized proteins as well as potentially different glycosylation forms that are present. Our assay has a 10% or better molecular weight resolution throughout that 10 to 240 kilodalton sizing range, and is also able to separate different glycosylation forms, such as the non-glycosylated heavy chain and heavy chain of the NIST monoclonal antibody with a specified resolution factor of greater than 1, though we routinely see that resolution factor closer to 1.6 or better.
I think that a lot of lab scientists will be very pleased to hear less pipetting. So, final question, some sample types such as crude lysates can be challenging for these automated systems. So can the proteoanalyzer handle this type of sample?
Absolutely. One of the key components of our assay is our conditioning solution. And this solution simultaneously cleans the capillaries of contaminant buildup while reconditioning that capillary wall. After the conditioning solution is flushed through the capillaries, we put in fresh sieving gel. And so between these two steps, we effectively reset each capillary between the samples, which allows us to analyze some pretty challenging samples. We have analyzed samples as dirty as crude liver lysate that was just centrifuged to remove the unhomogenated tissues, as well as neat trichoderma growth media supernate to identify overexpressed secreted proteins, for instance.
It's so great to hear that this is even applicable for those tricky samples. Well, unfortunately, that brings us up to the end of this quick session. So thank you to all of you who have tuned in today. And once again, thank you so much, Kyle, for joining me today.
Yes, thank you very much for having me today.
Thank you so much for watching this episode, and I hope that we'll see you again very soon.